In this video, we will take a look at a third apportionment method called the Webster method. Webster method, also named after famous Webster, Daniel Webster. You're going to notice the steps beginning again to look the same. Step one is exactly the same. Find the divisor the same way. Find the quota the same way. And then even step three is similar, but it is a little bit new. So I want you to make note of that, right? So you do write down the lower quotas as before, but the difference is you're going to see this word in purple right there, right? You're going to round. Okay, before we've been chopping off the decimals, just like getting rid of them. And now we're going to use rounding rules, right? And remember our rounding rules that if it's 0 through 4, we go downward, right? And if it's 5 through 9, we go up. Let me give an example of that. Like if you find a quota to be 28.3, you would round that to 28 because that falls in the category of 0 through 4. But if you had 28.7, the 7 being in the 5 through 9 category, you would round that up to 29. All right, that's the rounding rules. Now, what can happen is because we're rounding, it can be really nice at times. What can happen is you actually do the problem and you're done, because when the rounding works so well that you have exactly the right number of seats, you're done. All right. But you may not. You may have too many. You may have not enough. Because we're rounding, we can go up and down. So step 4 is also new, although somewhat familiar. But if the total from step 3 was less, you need to reduce the divisor. Now, that's what we did with the Jefferson method. All right. But since we're rounding, we can go up. That can mean that if the total from step 3 was larger, then you need to increase the divisor. All right. So you might reduce, you might increase, depending on whether it's bigger or smaller. Or as I said before, it could be that it turns out to be exactly right and you're done. Let's take a look at the same examples and see what happens. Again, this is our first example about the Bandana Republic. These 4 states that have this population. Actually, that number is wrong. It's a total of 8 million people down here, right? 8 million in the population. And we're going to see what happens as we go through these. This time I'm going to exclusively use technology, but again, you can do this by hand with a calculator. So using Excel, I already have the population in there. I have the total population. Let's recall that the way we calculate our divisor is to take the total population. I'm going to hit equals, the equal sign. I'm going to click on the total population. I'm going to divide by the number of seats, or whatever it is we're divvying up. Remember, in the problem, we have 160 seats, okay? So I'm going to divide by 160, hit equals, and just like the other times, our divisor is 50,000. When we go to our quotas, we're going to hit equals, the state population divided by the divisor, hitting equals. Remember my trick I showed you on the Jefferson Part 2 video is if you put a $ before and after the B, you're able to go to the corner and drag that formula. All right. Now, so this time, here's where it's different. Step 3, the initial apportionment. We don't just chop it off, we round. Now, you can round by hand. You can go, okay, 66.2, that rounds down to 66, 53.4, that rounds down to 53, 26.6, that rounds up. So I'm going to round up to 27, and 13.8, that rounds up to 14. If you want to do it by hand, you can do that. If you want to use the computer to do that, that can be done as well. I'm going to show you how. You would just go to the first cell and you would equals. Equals means I'm going to type in some kind of formula. And the command is just round. Round, parentheses, right? Click on the quota. That's what you want to round. Comma, 0. You want to round it to the nearest whole number, so no decimals. All right. That rounds it to 66. You can go to the bottom corner and drag that formula and see you have the same answers. When we add this up, something beautiful happens. Whoa. What happens? We get 160. Wow, we are done. Very excited. This method is kind of cool like that because sometimes, as soon as you do the initial apportionment with rounding, we actually rounded 2 of those up and 2 of those down, and it picked up those 2 seats that we missed the previous time. You'll also notice the apportionment is different with this method than it was with the Jefferson. In the Jefferson, the 2 larger states got the extra seats. In this method, the 2 smaller states got the extra seats, just like in the Hamilton method. So that actually is our final answer right there. Okay, let's take a look at that second. So right there, by the way, right there, the modified divisor, right? A modified divisor was not required, right? Not oops, not needed, all right? But we might need it in a different example. Let's take a look at the other one. All right, so other example was the one about the city buses, right? We have these 6 routes, these different numbers of passengers, and we're going to apportion the 130 buses. I'm also going to use Excel for that. Here is that problem again. Remember, our divisor equals the total population divided by the number of seats, or in this case, the number of buses. We're divvying up 130. Our divisor is 1,000. Again, we're going to calculate the quota by hitting equals, taking the bus population, average population, and dividing by the divisor. All right. I'm going to go back to that, put a $sign before and after the B so that I can repeat that formula a bunch of times. And I'm going to take a whole lot of shortcuts. I'm going to round, right? I'm going to round this quota to the left, comma 0, that rounds it off to the nearest whole number, and we get 45, and all these are going to round off for me. And then I'm going to click on this bottom one. I'm going to hit the sum button up here and hit enter. It's going to add all those up. Wow, so close. Notice I have, I need one more, right? I need one more. Now, if you're doing this by hand, this would also be exciting because you would see you don't have to adjust the divisor that much. All right, so we're short a seat. We need to add one more. Now, let me remind you that with this method, with a Webster method, you might go up, you might go down. Let me review those rules for you one more time, right? It was in step 4, right? And it says if the total from step 3 was less, I'm crossing it out rather than highlighting, was less than the total number, and that's what we had, right? We added up to 129, we wanted to 130, then you need to reduce the divisor. That's what we did in the previous method, in the Jefferson method, right? This is, by the way, remember, this is the Webster method. So that's what we're going to do. But if we had a number bigger than 130, like if we had 131, we would have increased the divisor. The cool thing about technology, you can do it rather quickly. So I need to reduce to 1,000. So maybe I'm like, 900. Now notice I don't need one more, right? I need 5 less. I went way, not 5, 15. I'm at 145. That means I went way too far. So let's try just 950. That's 138. Oh, I didn't need to adjust it that much. Let's just try 970. That's still 135. Ooh, 980. That's 132. Wow, I didn't need to reduce it hardly at all, at 990. Still 131. Remember, my original divisor was 1,000. Let's try 993. Still not enough. 995. Still not enough. 997. Got it. Isn't that crazy? I only needed to reduce my divisor by 3. And again, this is what I talked about in a couple of videos ago when I said, when you change in the divisor, how much do you change it? And the answer is, well, who knows? It depends. The answer, unfortunately, is it depends. And that's why I'm showing you how to use technology. It can really save you the trouble of guessing and checking a bunch of times and redoing it by hand. Notice when I have it set up with technology, the answer is automatic. I'm snapping my fingers, automatically populates, and I got it. So that would be my final apportionment right there. I don't recall how it compares to the previous method, the Jefferson method, but this, again, was a video on the other method, the one that we just did, the Webster method. All right, have a good day.